Welcome back. If you've ever found yourself staring at an alphabet soup of statistical variance and wondering where to even begin, you are in exactly the right place. Today, we're building your ultimate analytical toolkit. By the end of this explainer, you're going to have a rock-solid framework for knowing precisely when and why to use ANOVA, ANCOVA, and MANOVA. Let's get right into it.
Picture this. You're sitting on thousands of data points. You just ran a massive, exhausting experiment. But how do you actually prove to anyone that your intervention worked? To separate the true signal from all that random noise, you have to ask the data the right statistical questions.
So, here is our roadmap for today. We're going to cover comparing groups, ANOVA, ANCOVA, MANOVA, the strict rules of statistical assumptions, and finally, real-world data in action. We'll start simple and then progressively add in some real-world complications.
Starting with Section 1, Comparing Groups, the basics. This really is the foundation of almost all experimental research.
We all know and love the independent t-test, right? It's fantastic for a simple A versus B comparison, but it's got a major limitation. It only compares one construct consisting of exactly two groups. The second your research gets even slightly more complicated, like what if you have 3 groups or 4? That t-test hits a massive wall.
Which brings us to Section 2, ANOVA, Analyzing the Variance. This is where we pull out our first heavy hitter. ANOVA stands for Analysis of Variance. It's the technique you use to compare the mean scores of more than 2 groups on a single continuous dependent variable. Think about comparing the effectiveness of 3 totally different teaching styles, say whole class, small group, and self-paced learning, on math scores. ANOVA is exactly the tool you need to figure out if there's a real statistical difference between those 3 distinct groups. But how does it actually work under the hood? It all boils down to signal versus noise. ANOVA calculates what's called an F ratio. It takes the variance between your groups, that's the signal, the actual effect of your teaching style, and divides it by the variance within your groups, which is just the random noise of individual differences. Basically, a large F ratio is the proof you're looking for. It indicates your intervention actually worked and your results didn't just happen by pure chance. All right, Section 3, ANCOVA. Controlling for covariates. Because let's be honest, real-life data is rarely as clean as a basic ANOVA requires.
What happens when annoying outside variables start muddying the waters of your pristine study? That is when you deploy ANCOVA, or Analysis of Covariance. This explores differences between groups while statistically controlling for an additional continuous variable, which we call a covariate. So when you highly suspect some outside factor is influencing your dependent variable, ANCOVA lets you just mathematically filter it right out.
To put that into perspective, imagine you're running a fear of statistics workshop and you're measuring post-test anxiety scores. The glaring problem? Some students were already absolutely terrified before they even walked into the room. We'd use ANCOVA to control for those initial pre-test anxiety levels. By statistically removing that pre-existing difference, we get to see the true, isolated effect of the workshop itself. Pretty clever, right?
Moving right along to Section 4, MANOVA, Managing Multiple Outcomes.
You step up to MANOVA, which stands for Multivariate Analysis of Variance, when your study involves more than one dependent variable. And importantly, those variables are conceptually related. What MANOVA does behind the scenes is actually kind of brilliant. It creates a brand new summary dependent variable, which is a linear combination of your original variables, and tests that combined outcome across your groups. And by the way, quick pro tip, if you ever need to do this while also controlling for covariates like we just talked about, you'd use a MANCOVA, which combines both concepts into one super tool.
So, side by side, it's pretty straightforward. ANOVA handles just one continuous dependent variable. But if you're evaluating, say, a psychological intervention's effect on both negative mood and perceived stress simultaneously, MANOVA is absolutely your required tool. It handles more than one continuous outcome at the exact same time.
Now, a lot of folks wonder, why not just run a bunch of separate ANOVAs for each outcome? Well, doing that massively inflates your risk of a type 1 error. A type 1 error is a false positive, meaning you find a statistically significant result that isn't actually real. The real magic of MANOVA is that it mathematically controls and adjusts for this increased risk, ensuring your findings stay scientifically valid.
Section 5, Assumptions, Rules of the Game.
You can't just plug numbers into software and hope for the best. Using these powerful mathematical tools means you have to play by strict statistical rules. Before running something like a MANOVA,
Your data has to check a few crucial boxes. You need an adequate sample size in each cell. You need normality. You absolutely must have an absence of extreme outliers, linearity between your dependent variables, and homogeneous of variance. These tools are incredibly sensitive, so checking these assumptions beforehand is totally non-negotiable.
Finally, Section 6, Real-World Data in Action. Let's see how researchers actually use this stuff.
Think of this breakdown as your ultimate cheat sheet. It perfectly maps the complexity of your research question directly to the right tool. Got one independent and one dependent variable? You're using ANOVA. Need to filter out some outside noise with a covariate? That's ANCOVA. Dealing with multiple dependent variables all at once? Break out the MANOVA.
Let's see this in the wild with a study on Roman heritage tourism. These researchers wanted to know what actually makes tourists want to come back. They didn't just look at one isolated factor. They deployed advanced statistics, specifically running a MANOVA on motivation scores to untangle a complex web of event involvement, experience authenticity, and place attachment, and how all of that drives a tourist's intention to return. They had multiple related outcomes and deeply nuanced segments. Only a multivariate approach could handle that level of real-world complexity.
At the end of the day, your data tells a compelling story, but only if you ask it the right questions. So the next time you're staring down a massive dataset, which tool will you use to uncover yours? Whether analyzing Roman tourists or trying to cure a fear of statistics, you now have the exact analytical toolkit to find the true story hidden inside the numbers. Thanks for joining me on this explainer. Keep asking the right questions, and I'll catch you next time.